improper fraction to mixed number to improper fraction thing kind of as a little bit of review, and it's going to come into play. I want to review before we do that how we solve proportions, because we're going to be working with some more proportion stuff today, and a lot of it actually. Well, so let's go back to a regular old easy problem. And it's, when I'm recording, it's a little bit delayed, so you just have to bear with me here. 4/5 equals x over 3. How did we solve a proportion like that? What's our process, Ryan?
4 times 3 divided by 5.
Okay, so we're taking the cross products. It's called the butterfly method. So you have 5x equals 4 times 3 is 12. And then you divide by 5. And so x is 12 over 5. And I had a question on the test the other day in the other class that they said, hey, this says what number is my answer? And I'm getting a fraction. Well, a fraction is a number. It's okay to get fractional values for these answers. Okay? So we did that to start off with proportions. Then we had fractions in our proportions. Something like this. It'll look like this, and then we do the same process with it. We're going to take our cross products. So we have 3/4 x equals, and then we take 1/2 times 1/5 is 1/10. And then Austin, how do we solve for our variable on this? 1/10 divided by 3/4, and dividing by 3/4 is the same thing as multiplying by the reciprocal. So I'm just going to write that as times 4/3, if it will keep up with me here. Times 4/3, 4 and 10 reduced to 2 and 5. So x equals 2/15. So those are the two types of proportions that we've been working with. And then this is part of today's lesson. What's different about this fraction, Ethan? Or about this problem?
That they have, the two on the right have whole numbers.
Okay, so those are called what? Mixed numbers. What do we have to do with mixed numbers when we're trying to multiply or divide?
Change them into improper fractions.
Change them to improper fractions. So let me slide this up, if it'll grab it. And I'm going to rewrite it. The left side's going to stay the same. 4/9 over x equals, Mary, what's the improper fraction for 2 and 1/5? 11/5 over the improper fraction for that one, Josh, is 7/4. And then we do our cross products. We're going to take 11/5 times x is 11/5 x. And that's going to equal 7/9. So you can go ahead and multiply 4 times 7 and 9 times 4 to get 28/36. 28/36. Or you could reduce those 4's when you're multiplying it, or reduce by 4 at this point. 28 over 36 reduces to 7/9. So I'm going to write that as 7/9 there. 7/9. Jaron, what do I do to solve for the variable now?
Divide them.
Okay, what order?
11/5 times 9/7.
Flip-flop that.
7/9 times 11.
Right, we're taking the number that's by itself times the reciprocal of the coefficient, the number with the variable. So 7/9 times 5/11. There isn't anything that reduces, so you multiply across, you get 35/99. Okay, switch gears. We'll come back to proportion in just a minute, but I want to switch gears for a minute. What do they call those pieces of paper that are about yay big that they have drawings on them of houses and stuff? Anybody know what those are called, Austin? Blueprints. Austin, what are blueprints used for? To map out a house, and who needs them?
Architect.
The carpenters, the electricians, the plumbers, everyone that's working on that house takes information from the blueprint and makes sure that they put things where they're supposed to be, and that they build things with the right measurements. Okay, now when the carpenter and the electrician and the plumber and all those guys go build their house, do they build it the size of the piece of paper?
No.
Why not?
There's a key on it. Cause you couldn't.
There's a key on it. What do we call that? Any idea? What do they call those keys other than legends? If you get a map and you're this far on the piece of paper represents like 500 miles, what do they call that thing?
Maybe like graph, like.
An equivalent?
Kinda. How about a scale? Is that what you're looking for, folks? That was the word you were looking for. It is a scale. The blueprint is a scaled down image of what the house should be. Now, when they take the blueprint and they go build the house, what should be true about those two things?
The scale and the actual size should be the same. Needs to be exact.
What do you mean by exact?
Like it has to be like right, or else like if you like make the floors, if like you make the bottom floor smaller than the top floor, then the house is gonna go out like
Right.
this.
So everything that's drawn on that blueprint has to be transferred by scale to the real thing. And so when you get done with the house, shouldn't it look like what you started with on your scale? Shouldn't they be similar? What's not similar about them is their size, isn't it? They look the same, they just are different sizes. We're going to talk about similar triangles. If two triangles have angles with equal measures, the triangles are similar triangles. If you notice, I have these marked with some marks in the angles. I call these tick marks. So when looking here, we have one little dot or one line through that angle. We have one here. That's saying that those two angles are the same measure. They're equal in measure. So these two have, or this angle here and this one here, have two tick marks, so they're equal. And then obviously then the other one have three tick marks and they're equal. So these two triangles have congruent angles. What does the word congruent mean? Equals. Congruent means equals. Their angles are congruent. Are their sides? No. Their sides are different lengths, but their shape is the same. They are similar. When the angles are the same, but they're different sizes, they are called similar. They're not called congruent because they're not the same shape, or they're not the same size. They're called similar. And in similar triangles, corresponding sides are proportional. Well, what's this word corresponding mean? Lots of terminology today. Sydney, what does corresponding mean?
To me, they're like the same side.
Good. They're lined up. They're the two that match up. If I were to take the little one and just make it a little bigger and lie it on top of the bigger one, the sides that are on top of each other there are the corresponding sides. The angles that are with each other are the corresponding angles. Okay? So it's saying that the corresponding sides of similar triangles are proportional. What does that mean? That means if I take, let's start with the 2 and the 3, the sides 2 and 3. If I take 2 over 3, write that as a fraction. If I take the corresponding sides in the other triangle, they should match up. Which length in our bigger triangle matches up with 2, Taylor? Or corresponds with the length of 2? 4. So I'm going to write the length of 4 across from 2. What length, Kirsten, corresponds with 3 in the bigger triangle? Length 3, what length corresponds with it over here? 6. Does 2/3 equal 4/6? If you reduce 4 over 6, wouldn't it reduce to 2/3? And the other way to check this is that their cross products should be equal. 2 times 6 is 12, 3 times 4 is 12. They are indeed proportional. You could take any pair of sides as long as they were the corresponding and match them up, and you'd get that it's proportional, or that they're equal whenever you do your cross products. Okay? So corresponding sides of similar triangles are proportional. You'll get to a theorem in geometry as sophomores that says corresponding sides of congruent triangles are congruent. This is talking about corresponding sides of similar triangles are proportional. So we're going to use this information to help us find x and y. So let's start with x. And I'm going to put x up here and then we'll talk. To determine what values you put under your x and across from your x, there's actually 2 different ways we could do this. X has 2 specific numbers that it's related to. Okay. One of those numbers is that it has this number 3 that's a part of the same triangle. So x is related to 3. Okay, it's like a brother or something. All right. And then it's also related to the number 4 because they're corresponding sides, kind of like a cousin. All right. Now, the number 2, if you look at the number 2 and the number 5, let's just say the number 2. The number 2 is kind of like the cousin's wife. Are you related to your cousin's wife by blood? You better not be, or that could be pretty sick. Right? Yeah. Yeah, Lake of the Ozarks area too, where my family's from. I've told you that one. Right? Yeah, I did in class, that's right. I won't bore you with it again. So, X is connected to the 3, or it's related to the 3 and the 4. So I can put either the 3 or the 4 underneath X, and it doesn't matter, I'm going to take it over the 3. And then it's going to have the number 4 as the other one it's related to across from it. Now, which number is related to the number 3? 2. So I have to take that one there. The x and 2 are not related, so they have to be diagonal of each other. Okay? Now, don't take that and try to figure out why 3 and 4 aren't related, because there's an adoption or something that took place there. They're not blood, but they're related or something like that. Okay?
By marriage.
Don't reach into it. Don't go for
You're
it.
saying math is just like a soap opera?
Well put.
It's like Family Feud.
Okay. So to work this out, and I'm actually going to do this another way in just a second, but we have 2x. 2x equals 12. So x equals 6. Now, if someone else had decided, you know what, I'm going to take x and put it over the corresponding length that it's related to, a 4, and then went, okay, it's connected with 3 because it's a part of the same one, put it 3 over, and then 3 still corresponds with the 2. Isn't this going to give you the same thing as this? X times 2 is 2x. 4 times 3 is still 12. Aren't these two things the same? So it doesn't matter which value you put across from x and which one you put below, as long as x is related to it. Okay? It either needs to correspond with it, or it needs to be, that link needs to come from the same triangle. I'm going to erase this. I'm going to erase this. There we go. And we're going to solve for y. Addie Mae, give me a number that y is related to.
5.
5, so I'm going to put y over 5. Miranda, what's another value that we know y is related to?
3.
3, that's right. And then Ryan, what would be the number that 3 is related to? 2. So you have 2y, and I'm going to bring it this way. 2y equals 15 when you take your cross products. Divide by 2. Y equals 15 over 2. Or, if you want to write 7 and 1/2, you may. Either answer is okay. Ben, are these two triangles similar?
No.
Why not?
No, one's smaller.
One's smaller, but what about their angles?
They're the same.
Their angles are all the same, so if their angles are all the same, then they would be similar.
But
They're not congruent, they're similar. Jaron?
You just said what I was.
Okay. Alright. So they are similar, that means their sides are proportional, and I'm trying to find m. Mitch, what's one of the lengths that's related to m?
4.
Okay, so m to 4. Cameron, what length am I going to put across from m then?
9.
9, because that's the corresponding length. And then, Ethan, what number is going to go on the bottom underneath 9?
5.
5, because that corresponds with the 4. So we have 5. So you have 5m equals 36. Divide both sides by 5, you get 36 over 5, or 7 1/5 if you want to write it as a mixed number. Taylor, going to solve for p. What length do you want to put under p that it's related to? 7. Josh, what length are we going to put across from it? 5? Is p related to 5?
No.
No, it's related to 7, so it's not going to be related to these other two, so we got to go to the triangle that it's a part of.
4.
4. Camo, what are we going to put on bottom then?
5.
5. Okay. Ryan, how do we solve this? It sounded like you said 5p. I'm sure that's not what you said, but it sounded like it.
Huh?
Carry on.
What? I didn't say 5.
Yeah, that's what I thought, but it
You
sounded
should.
like it.
I did 28 divided by over 5.
Right.
Or-
So it's, you take 5 times p is 5p, 7 times 4 is 28, and then you divide by 5. So 28/5 or 5 3/5. Okay. Anybody have any questions about that? Now let's suppose I told you this. Are similar. So the book's only going to show you triangles. But I'm going to tell you here that the rectangles below are similar, even if they don't look like it. You're going to have to trust me. Okay, go off of what this says. If this is 3 and this one is 7, let's not do 7, let's do a nice number. Let's go 8. 3 is not no. Ooh. Let's try again.
No, it's not.
3, 6, 3, x. Could we set up a proportion, Tony, that would allow us to solve for x? First of all, are the sides going to be proportional?
Yes.
Why?
Because it's a
They're similar triangles, so even though it's not a triangle, the sides are still proportional if they're similar. Okay? So how could I set up the proportion then, Tony?
3 over x.
Okay, so you're taking this 3 over that x?
Yeah.
Okay, so that 3 over x. Okay, so this 3, what other number's related to that 3?
6.
The 6. And then what's related to x is 3. Then do your cross products. You get 6x equals 9. X equals 3 halves when you reduce 9 over 6 to 3 over 2. Right? Sound beautiful?
Yes.
You can apply this to any similar shapes. That's how you do scale drawing. That's why we do it. We used to study that in test prep. Was specifically solving for scaled values. We're not going to be doing that now. All right, your assignment. It's problem set 65, 1 through 30. That is due Friday.
Mr. Clevenger?
Yes?
May I use the restroom?
Yes, Mitch?
Can you go back to the problem?
Uh-huh.
If the numbers can reduce, can you just like divide?
You could have. We could have made that 2 over 1 here. Is that what you're talking about?
No, like see how 6 can be divided by 3 to 2. So
Right.
could you divide 3 divided by 3 divided by 2?
No, it would have to be this. This reduces to 2, this one reduces to 1. And then you have to do your cross products to make sure you get, it's 2 times x equals 3. And then divide by 2. So it's 3 halves. If you do it the other way, you had it inverted. You had the reciprocal value.
Right.
If you're meaning the right thing, you're just saying it wrong, then yes, you can do it that way. Now, if you have a question, go ahead and keep going on this.
Like if the 2 top numbers
Mm-hmm.
on the rectangles, 6 and 3.
Uh-huh.
If you can reduce those somehow, could you reduce 3 and make
What would you have to do to 6 to make it 3? Divide it by 2.
yeah?
So you'd have to divide this one by 2, which is 3 over 2. Yeah.
So you can find the
Yeah,
answer
you could
with
do that. Uh-huh. It's the same deal, essentially. It's just,
Mr. Clevenger,
mm-hmm.
since you play basketball in college, like